Hello everyone, welcome back. In this video, we will explore two fundamental transformations in Apache Spark, Map and FlatMap. These functions are crucial for data transformation in distributed computing. So let's break them down. Both Map and FlatMap are higher order functions in Scala, which means they take functions as arguments. I'll create a separate video to explain in detail about higher order functions in Scala. So map and flat map are basically used to transform data, but they do so in slightly different ways. So let's start with map. It's a transformation that applies a function to each element of an RDD or a dataset, creating a new RDD or dataset with the same number of elements as the input RDD or dataset. Think of it as applying a transformation to every item in a list. For example, say that we have a list of numbers with 1, 2, 3, and 4, and we would like to apply a function to these elements in the list. Let's assume that we would like to double every element in the list. For doing so, we apply a map for this list and we provide the function to double the elements as a function to this map. Let's say that we are putting the list in a table format. So we have an input. Input is list of numbers 1, 2, 3, and 4. And we are going to apply map on the input numbers, which is nums dot map. For map, we are passing the double function as a argument. So for every element x, it is going to do x into 2. So the function that we are going to apply is going to be into 2, multiplication with 2. When we multiply 1 with 2, we see the result of 2. Same when 2 is multiplied with 2, it's 4, 3 into 2 is 6, and 4 into 2 is 8. So this is going to be our output. That is, for every element in the input, we get an output. So our output is going to be a list again with the numbers 2, 4, 6, and 8, which is the double of the input list. Let's try to code this out. And I have created an object in Scala and I have initialized a main function and created a Spark session. And the Spark session also has spark.stop at the end, and anything that we do in Spark and Scala will go in between these two lines. And this is the basic structure that I follow for all my videos. If you have not watched my videos where I have explained everything about object, main class, Spark session, please go to the playlist and watch them to have a better understanding of what we are doing here. I am creating a variable, I am calling it nums, and I am assigning a list of 1, 2, 3, and 4 for this nums. And for this nums, I am applying a map. It will take every element and it will multiply that element by 2. Let me assign this to some other variable called doubled nums, and I would like to print this double nums and see what it is going to display. Let us run this, and as you can see that it has displayed the list, which is 2, 4, 6, and 8, which is exactly the double of the input list as we have applied the function x into 2. Let's say that if you want to add 2 or x plus 2, if you change it with x plus 2, so it will add 2 to every element of the list and it will print out. Let's check this out. So basically this x plus 2 or x into 2 is going to be the function that we are going to pass as an argument to this map. So map will basically accept function as an argument. Instead of passing the variables or numbers or string or anything, we pass functions to some functions in Scala, and those functions are called higher order functions in Scala. As we are able to pass this function to this function, we are calling it as a higher order function. And you can see that so every element is added with 2 and we see the result is 3, 4, 5, and 6. So to understand map more clearly, I have one more example. Let's say that we are having a list now with two sentences. The first sentence is hello space world and the second sentence is atomic space engineering. Let's put this in a table to understand clearly again. Now I have put this input in a table. So we have two elements in the list, hello world and atomic engineering. And let's do a split of this sentence into words. So we are going to apply split function based on space. So whenever it encounters a space in the sentence, it will split that into words. So the split function will basically split this input and it will convert into words, and the words are put inside an array. And same way the atomic engineering will also be split into words wherever it find a space, and it's converted into an array. So the same way in the previous example we had one output for every input, here also we have one output for every input. So it's a kind of one-to-one mapping when we do apply map function for any dataset or RDD, and our result is going to be again a list. List contains two elements. The first element is array of hello and world, and the second element is array of atomic and engineering. So feeling complex? Let's try to code this out and see how simple it is. Let me create another variable called input, and I'll put hello world as the first element, and the second element is atomic engineering, and I'll create one more variable called output. Output will be basically input mapped with split, splitting based on space. We have a space here, so I am splitting this, and let us print this out. So if we print this output, we should see something strange other than an array, because we cannot print an array as it is. For printing an array, we need to print each and every element, or we need to convert that array into a list and then print it. Let us try to run it as is and see what it shows us. We can see that it has printed a list. List contains two elements. The first element is of Java, lang, string, and the second also contains the same. Because it's basically an array, so array needs to be converted into list or sequence to get it printed. Let me convert this to list to see what's inside it. Now if I run this, we should be able to see the exact items in the list. So we can see that the output is a list, and the list contains two elements. The first element is again a list of two words, hello and world, which is split from the input that's here. And the second element is again a list, which is the sentence split into words, atomic and engineering. So this is how, using map, it's a one-on-one mapping. So if there are n elements in the output, for every element in the n, there will be a mapping in the output. So the mapping will be the input applied with the map function. Whatever the function that we have provided to the map, that will be applied to the input and shown in the output. And let us also understand flat map with the same example. So flat map is basically very similar to map, but it can produce a different number of elements for each input element. Basically, it flattens the result into a single RDD. So if you look at the same input, the list containing two sentences, the first sentence is hello world and the second sentence is atomic space engineering. Let's put this into a table again. The input is hello world and atomic engineering, and the function that we are going to apply is going to be the same function that we have applied to the map. If we apply flat map instead of map to this input, we are going to see a different output, which is we are going to see two elements for the same input hello world. So these two elements are basically flattened version of the output. That's why we call it as a flat map. So the result is usually an array containing two elements, but the array is flattened out into individual elements again. So hello world, which produced array of hello and world with the map function has flattened the hello and world. The same way atomic engineering will be split into atomic and engineering, but the result is again flattened. So for the input containing two elements in a list, we are going to get an output with four elements. So FlatMap can produce different number of elements for each input element. So result is going to be again a list with four elements: hello, world, atomic, and engineering. So interesting. So let's try to code this out as well. Now for the same input, I'm going to create one more output, calling it as FlatMap output, and I am doing input dot flat map, and I'm going to apply the same function, which is splitting based on space, and let's print flat map output and see what it is printing. So we can see that it has printed hello world, atomic, and engineering. See the difference between map output and flat map output for the same input. So the basic difference between the map and flat map is like for the same input, which is list of hello world and atomic engineering for the same function where we splitting based on space, map output is array of this and array of this, and flat map output is the flattened version of the map output. So this is the basic difference between the map and flat map. So if you like this video, please do hit like and subscribe to my channel if you are interested in more content related to data and analytics. Thanks for watching. I will attach the link to this code in the video description so that you can practice that in your systems. See you in my next video.